Welcome to the Commercial Lighting Commissioning Technician course. Let's take a moment to look at some of the properties of low-voltage circuits. The National Electric Code defines the properties of low-voltage circuits in detail. Please ensure that you're familiar with all the sections of the code prior to working with both high and low-voltage electrical equipment. NEC Article 725 provides some details regarding the classification of remote control circuits. Since we use remote control circuits for lighting control, it is important to understand these classifications. Control circuits may be divided into three different classifications by examining their electrical characteristics. Class 1 circuits are usually supplied by a power-limited source, but may be of a higher voltage, such as 120 volts. Classes 2 and 3 are generally lower voltages. Whereas Class 1 circuits are permitted by design to travel adjacent to primary power circuits, Class 2 and Class 3 must travel separately. Class 2 and 3 circuits are powered by a separate low-voltage power supply, which is protected by some overcurrent method such as a fuse or circuit breaker. Class 2 circuits use a voltage and current which would not present the risk of shock, but Class 3 circuits can be of a higher voltage which would represent a shock hazard. Overall, however, both Class 2 and 3 are generally considered to be low-power signals. Another consideration to be made when using low-voltage power, such as 24 volts DC in a system, is the length and gauge of the cable being used. Although the formulas are fairly complex, they can be simplified into a basic rule of thumb. The larger the diameter of the cable, the further you can send voltages without losing a significant amount. As you can see from our examples, 24 volts traveling 100 meters would benefit by traveling over number 10 gauge cable in order to achieve a useful voltage at the end. Preserving the integrity of either analog or digital low voltage signals is critical, since we want to maintain reliable and replicable control of our lighting devices. Since the environment that the cable is installed in may have sources of electrical noise, either electrical or magnetic, in close proximity to the cable itself, we have to take steps to prevent this noise from affecting our control signal. One method that can be used is known as balancing. A balanced cable uses two wires for every control signal, using a second wire in the pair as an inverted version of the signal. Inverting is where a positive voltage is turned into a negative voltage and vice versa. By comparing the two signals, a receiving device will be able to determine which of the voltages are intentional and which are merely caused by interference. Another method that can be used is shielding, which stops the interference from entering the cable. A shielded cable is covered in a metallic jacket, usually made of metal foil or a copper-braided sleeve. When terminating this cable, the jacket is connected to ground. Since the entire cable is covered by this conductor, any interference which enters the assembly will be diverted and sent to the ground connection, rather than passing into the control signal conductors themselves. Thank you for watching.